Hello, Algebra 2. Welcome to the final section of Chapter 4. I know it seems like it's gone on forever, but it's a pretty important chapter. So all we are going to be doing in this section is looking again at how to write a polynomial function from a graph, and from the data tell what type of polynomial you have. So that's our goal for this video. So we have the general form of a cubic function up here. So basically any polynomial is going to follow this same form, but this one, since the highest degree is 3, makes it a cubic. If we look at the graph, we also see that looks like it's a cubic. How do we know? We have 2 turnarounds. We cross the x-axis 3 very visible times. We can also tell from this graph that our lead coefficient should be a negative number. And what we're going to do is we are going to come up with the equation of the cubic function that goes with that graph. But we're going to keep it in intercept form. So we're going to come up with an equation based on x minus root 1, x minus root 2, x minus root 3. So we will be able to see those 3 roots on the x-axis. All we need is then a 4th point to give us a particular x and y, and then we can solve for a. So let's do this. So we know that our roots are going to be, I see a negative 4, then we see a 1, and then we see 3. Those are where you cross the x-axis. So remember, those are your roots, your solutions, your x-intercepts. But what we also want to draw attention to is we need this 4th point. We need a particular xy value, which is 0, negative 6, in order to solve for a. So let's start the process. So we have y equals a, x minus a negative 4, that's our root 1, x minus 1, x minus 3. Everything looks okay except we don't know what a is. So we go back and we plug in wherever we see a y, we plug in negative 6. We are trying to solve for a. So then we're going to plug in wherever we see an x. In this case, it's a nice number. It's going to be 0. So 0 plus 4, 0 minus 1, 0 minus 3. So this is going to give us the equation, negative 6 equals a. So what do we have here? We have a negative times a negative, so everything's going to be positive 12. And if we divide both sides by 12, we get that a is going to be a negative 1/2. And then we put everything back together. So y equals a negative 1/2. Notice we expected that lead coefficient to be negative. And here are our roots. That would be your final answer. Okay, the last thing we're going to look at is something we've already looked at actually. We're going to look at the concept of constant differences or common constant differences. So we know that if you just go through and take the difference in the x values, the difference in the y's, and everything is a common difference, that gives you a linear function. We looked at when you did it again, if you didn't have a linear, the second common difference was going to be a quadratic, and following in that vein, if you didn't get a quadratic, you would then continue, and if the third common difference is constant, in other words, it's the same value, then you know you have a cubic function. So you have 3 levels to go now. So let's go ahead and check this one out. So we know 2 minus 1. We see all of these are going to be plus 1, plus 1, plus 1. And again, it is still the idea of the ratio of the y over the x. But in this case, all our x's are 1. So let's look at what's happening with our y values. So 4 minus 1 is 3. 10 minus 4, 6. 20 minus 10 is 10. 35, so that difference is 15. Then we get into, what is that, 21. And this is going to be, I believe, 28, but you want to be careful. And that is what it is. Okay, obviously that implies this is not a linear function. Those would all be the same number if it was a linear function. So let's do the next difference and see what we get. 6 minus 3 is 3. This will be 4. This will be 5. 6, 7. It is a pattern, but it's not the same number. That tells us this is not quadratic. And voila, we don't have a lot of work to do here, but I noticed that the difference between every single one of these is now 1. That is my constant difference, and the fact that it took me 3 times to get to it tells me this represents a cubic function. Now I want you to appreciate the fact that all you have to do is identify whether it's linear, quadratic, or cubic. You don't have to find the actual equation. All right, that is it. We are done with chapter 4.